Today we begin our discussion of a very important topic in calculus called related rates. And it's how rates are related to each other. Okay. I want you to picture something. It's late at night, you're at home doing homework. It's about midnight and you're hungry. Okay? So you go to the pantry and you pull out a bag of microwave popcorn. It's time for a popcorn break. Okay? Does that sound good? Movie butter, good stuff. Okay. So you go and you unwrap the popcorn. You wrap it take it out of the plastic wrapper, stick the bag in the microwave, and push the popcorn button, and time starts passing. Now, as time is passing, what is changing? The amount of popcorn is one thing that's changing. What else is changing? The amount of unpopped popcorn is changing. Is anything changing about the bag? The size or the volume of the bag is changing. Now, let's go back to the let's go back to the popped popcorn. If you were to graph the volume of the popcorn over time, would it be straight? No. Can you picture what it would look like? How would it start out? It'd be slow at first, and then it would go really fast, and then it would level off, wouldn't it? So, as time passes, do things change at a constant rate all the time? No, they don't. The amount of popcorn in the bag does not necessarily change at a constant rate. It changes at actually it's called a logistic rate. We're going to be exploring some problems today where things are changing. Time is passing. Things are moving. Things are getting bigger. Things are getting smaller. And we're going to see how those different things are related. Do you think there's a relationship to the amount of popcorn and the volume of the bag? Do you think those two things would be related to each other? Yeah, because unless the bag gets bigger, there's no place for the popcorn to go. Does that make sense? So we're going to be looking at those kinds of relationships, and we're going to be talking about how they affect one another. Here's the first problem we're going to do. It says Phoebe is going east on Alamo Street at 40 feet per second. So here's the diagram they're talking about. Phoebe is walking east at 40 feet per second. That is her rate. We're going to have a lot of rates in these problems. Meanwhile, Calvin is going south on Heights Street at 30 feet per second. So here he's going down towards the intersection. Phoebe wishes to determine whether the straight line distance between them is increasing or decreasing. So in other words, we're looking at this line right here, part of that pen line right there. So as Phoebe moves east and Calvin moves south, how is that line changing? Is it turning clockwise or counterclockwise? What do you think? It's kind of going counterclockwise. It's going like this, isn't it? Till eventually it will be flat. So what we're going to do is we're going to explore the relationship between these two, and we're all of a sudden going to stop the line and see at that point, are they getting farther? Is the distance increasing or decreasing? That's what they're asking. Number one, let X represent Phoebe's distance from the intersection and Y represent Calvin's distance. Write the rates you know. Explain why dy dt is negative. Okay. Remember that dy dx means derivative, and it means the change in y over the change in x. These you remember from Algebra 1. So this right here represents the change in x over the change in time. So who is x again? Phoebe is. Okay? So what number do you think represents the change in Phoebe over the change in time? Which number did they break? What did it say? Her rate is 40. So her change in distance over time is 40. So we write 40 right here. Did y'all see where I got that from? Phoebe's rate, the rate and change of Phoebe over time is 40.
Wouldn't it be 40 t when you checked it?
Yes, it was. No, actually it was 40. No, it's a little more complicated. It's just 40 because it's a constant rate. Her rate is a constant change. Okay? Now, dy dt. So whose rate are we talking about here? Calvin's. Okay? Now it told me that it's 30. Now it gives you a hint here. It says explain why dy dt is negative, so it better be negative 30. Because he's going down. A couple of you said that. That's exactly right. It's not as much that he's going down. It's that y is getting smaller. Okay? Down or up doesn't matter, but it matters the fact that y is getting smaller. Okay? I don't want to go into that, but let's just put it this way. dy dt is negative because y is getting smaller. That's the reason. I would not put that it's because it's going down. That doesn't always necessarily mean that's true. It's because y is getting smaller. Okay? Any questions so far? All right. Let z be the straight line distance between Calvin and Phoebe. So, write the symbol for the rate you want. These two are rates because they have the dt on the bottom. Raise your hand if you think you know how we would write the change of z or z. Anybody want to give it a guess? Baranza? dz over dt is exactly right. We're looking for dz dt. Does that make sense to everybody? We're looking for the rate of change of z over time. Okay? Now, number 3, to find the rate you want, you need an equation relating the variables in the known and the wanted. So in other words, look at the picture. The picture tells you everything. Can you give me any equation that relates x, y, and z? Okay, it doesn't have to be even that complicated. Just let's make it even simpler than that. How are they related? Tyler, are you stretching? Okay. Can you give me an equation that relates x, y, and z? How would you write the Pythagorean theorem for this one? What letters? How would we put the letters?
X squared plus y squared equals z squared.
Exactly. Very good. X squared plus y squared equals z squared. Exactly. That's the equation we want because it relates all 3 variables. Okay. Moving up. Number 4. Differentiate. What does that mean again? Take the derivative. You need to know that. Differentiate both sides of the equation in the problem implicitly with respect to t. Okay. I need to take a detour for a minute and remind you of something. Okay. When we did this problem before, can you see what I'm writing? Oh, I'm going to have to move that up some more. X squared plus y squared equals 25. When we first started implicit differentiation, okay, we were finding dy dx, right? So let's go through. Everybody say this together. What's the derivative of x squared? 2x. What's the derivative of y squared? dy dx. Okay. Can somebody explain why we put the dy dx on there? We're finding the derivative with respect to x, but that's a y. Because the variables are different, we had to put dy dx. We're taking the derivative with respect to x, and that's not an x. Okay? And then the derivative of 25 was 0. Now, for this equation here, we're going to take the derivative with respect to t. Do you see any t's there? No. So every time you take the derivative, you're going to treat it like an x, but then at the end, you're going to have to put d, whatever that letter is, over dt, because we're taking the derivative with respect to t. Okay? So let's do the first one together. What's the derivative of x squared? 2x. But because it's not a t, we have to put dx dt afterwards. Plus, what's the derivative of y squared? 2y dy dt equals 2z dz dt. Y'all follow what I did? Because everything was not a t, I had to put a d, that letter, over dt at the end. That's how you differentiate with respect to t. Okay. Then it says to solve the resulting equation for dz dt. So I want to get dz dt by itself. What do? Divide by 2z. Now, we usually don't do this part where we isolate this dz dt. We're going to do it this time. 2x dx dt plus 2y dy dt, whoops, over 2z equals dz dt. All right. Now, once again, dz dt represents the change in that straight line that's rotating counterclockwise. We're trying to find out how much it's changing at the moment, at a specific moment in time. Okay? Now, just like the popcorn, that thing is not moving, it's not changing in length at a constant rate. We're going to have to find out what it is. So, I need to slide up to the top of the page here. Number 5 says, when Phoebe is 200 feet from the intersection, Calvin is 600 feet from the intersection. So basically, let me scoot this over a little bit. Basically, this line, they're slowly moving, time is passing, and we're going to all of a sudden stop it right here. when Phoebe's, I know my scale is off, but Phoebe's 200 feet away and Calvin's 600 feet away. We're going to stop it, and we're going to find out how fast Z is changing. Okay? So, we want to know, is the distance increasing or decreasing? We're going to use that formula at the bottom of the page, and we're just going to start plugging the answers in, plugging in the values that we know. So, here we go. We have 2 times x. Now, which one of these two numbers is x? The 200 is, because that's Phoebe's number. So 2 times 200 times dx dt, that's over here, that's 40, plus 2 times y, that's 600, that's the y, times dy dt is negative 30, all divided by 2 times z. I don't see a z. Now, what is z again? It's the hypotenuse of the triangle, right? And Brittany was just saying it is what? Right, so if this is 200 and this is 600, can you find z? Yes, take your calculator right now and do that for me. So, let's move it over. So we need the square root of 200 squared plus 600 squared. And I want 3 decimal places. 632.455 equals dz dt. Okay, now we need to go ahead and plug this into the calculator. I'm not going to do it the way I did it last period. I'm going to make it a little easier. Do the whole numerator first. So 2 times 200 times 40 plus 2 times 600 times negative 30. Get that answer. Now when you type in the denominator, you need to do it this way. You got to put both of those into a single parentheses. 2 times 632.455. Because if you don't, you get the wrong answer. You get something like 6 million. It's huge. So dz dt equals negative 15.811. Type this in. Is there anybody who's not getting this answer? Are we all good? Okay. Now, let me see. Jordan, can you look in the problem and see if you can figure out what the unit of measure would be for this? Feet per second? Yes, ma'am, you are right. It is feet per second because it is a rate. Now, Val, tell me if this is, so is the distance increasing or decreasing? What do you think? Based on that answer we just got. Decreasing. Why do you think it's decreasing? Exactly. So, the one last thing you need to do when you do these problems is to write this in a sentence. The straight line distance is decreasing at a rate. Now, should we write at a rate of negative 15 or at a rate of 15? What do you think? At a rate of 15. The decreasing means that it's negative. So 15.811 feet per second, period. I didn't realize my paper was so crooked. I apologize. Okay. Any questions? Barrett?
If the intersection wanted to start increasing again.
Yes, it will. Yes, it will. It will. Okay. Number 6. This is Paul Forrester. The man who wrote this paper actually used to teach at Alamo Heights High School, thus the names of the two streets. He just retired last year after 50 years of teaching. Can you imagine doing the same job for 50 years in a row? Amazing. But anyway, I love the way he talks because he's in his upper 70s and he talks a little bit, like an older person does. Naive thinking might lead you to believe that since Phoebe is going faster, because she's going 40, away from the intersection, that Calvin is going towards the intersection, that the distance between them should be getting larger. Does that make sense? If she's moving away faster than he's moving slower, you would think that the distance is getting larger. Does the calculation confirm or refute this conclusion? It refutes it, exactly. Okay. So, it might sound logical that it does that it would be getting longer, but it's actually getting shorter at that instant in time. Okay, number 7 is the very important one, because these problems can get rather complicated, but they're always done in the same series of steps. So, we're going to write a list of what we did in order to do this problem. So, number 1, first thing, identify the quantities given in the problem. They will always give you some numbers. What are they? Are they rates or are they values? In this case, sometimes they're rates and sometimes they're not. Number 2, identify, bless you, what you were solving for. Okay, that's exactly what we did in number 1 and number 2. First thing they said are, what are those two numbers, the 40 and the negative 30? They were dx and dy dt. Then it said number 2, what are we looking for? Bless you. Number 3, what did we do next? We wrote an equation. So write an equation relating your variables. So whatever variables you choose. They chose X, Y, and Z. You could have chosen A, B, and C. It doesn't matter as long as you're consistent. Number 4, take the derivative. This is the big one. Take the derivative with respect to t. It's always respect to t because we're talking about changes over time. Time is passing. We're looking at the changes. Okay? Next one, we plug in values given and solve for the unknown. Plug in values given and solve for the unknown. And then finally, write a sentence explaining what you have found. One of the things, let me finish writing before I start talking so I do it right. One of the things that businesses and colleges have discovered is that a lot of kids have trouble writing outside of English class. They can write fine, they can write an essay, no problem, but when it comes to writing for their discipline, math, science, history, it's not as good. So we practice writing what we're doing. And it also, when you write it in a sentence, a lot of times you're going, wait a minute, that doesn't make any sense. As soon as you write your sentence, you realize your answer's wrong and you go back and fix your answer. Okay, because a lot of times you'll do the math, oh, that sounds great, but then you find out that the balloon is rising in a negative direction and it's crashing into the ground or something, and something's very wrong. Okay, so these are the steps we're always going to follow when we do these problems. Okay, now, any questions at this point? Okay, the next part of the notes I need to hand out to you. What we're going to do is we're going to do this in baby steps. Okay, I walked you completely through that one. What I have for you now is another document that has these kind of problems, but it gives you steps to follow in order to solve the problem. We're going to do one together. The rest is going to be your assignment for tonight. Now, let's begin these problems. We're going to do number 1 together. I'm going to keep the problem right there. Now, this is different from any other sort of A, B, C, D type of question that you've done before. I don't necessarily want you to write A is this, B is this. This is thinking steps, okay? So, number 1. I want to read the question, and then we're going to work through the problem. It says, a spherical snowball is melting in such a way that its volume is decreasing at a rate of 1 cubic centimeter per minute. At what rate is the radius decreasing when the radius is 10? Okay, that's the way a related rates problem looks. And you may be thinking, I have no idea what to do with this problem. That's where these steps come in, okay? Part A says, what value does the 1 represent in this problem? Okay. Do you think the 1 is a rate?
Yes.
Okay. Yes. Myra, why do you think it's a rate?
Because it's centimeters cubed per minute.
Right. Its label is a rate of change. Centimeters per minute, something like that. Okay. So, now we know it's supposed to equal 1, but what equals 1? The other one told us dv or y dt or a dx dt. What are we going to call this? It's going to be a rate. It's going to be something over dt. I know that. Okay, let's use dV because it's volume. Okay, dV dt, capital V, dV dt. Good job. And it is cubic centimeters per minute. Okay. Now, keep reading. It then says, what effect, if any, does the word decreasing have on this number? It should be negative. So that's your cue. Oh, it's negative because it said decreasing. What is the problem asking you to find? So, always write down find something. What are we trying to find? Okay, that took care of the first sentence. At what rate is the radius decreasing? So we're looking for a rate, and usually you are. Find which rate? D what? dr dt because it's radius. Does that make sense? Find what rate the radius is decreasing when, and they will always give you a stipulation, when, and then it says what does the 10 represent? When what equals 10? When r equals 10 because it says the radius is 10, and I'm going to go ahead and put label on it, centimeters, because the label helps me label my answer when I'm finished. Okay? Now, on the last problem that we did, let me pull this back up for a minute. We were finding dz dt when Phoebe was 200 feet from the intersection and Calvin was 600 feet from the intersection. There's always a when. So you've got to write down, find this when this occurs. Okay? So, we've done part A. We didn't write A equals. We just wrote down what it walked us through. Part B. So, let's check that off. Write an equation that relates the variables listed in part A. So, what variables do we have? We've got a V. We've got an R. What are we talking about in this problem? Not a circle. A sphere. Right? Okay. So, does the formula for a volume of a sphere have V's and R's in it? Yeah, it does. Now, let me tell you this too. I've never said this before, and I should have done it on here. On the AP exam, they will never slight you a problem credit for not remembering a geometry formula. There is no formulas page on the AP exam. There isn't. But for a problem like this, they would put at the very end of the problem, note, the volume of a sphere's equation is this, and they would tell you what it is. Okay? So I'm going to tell you what it is. V equals 4/3 pi r cubed. There's your formula. They would give it to you. They're nice that way. Any volume formulas of like not prisms they expect you to know, but cones and pyramids and spheres, they'll give it to you. They'll always give it to you. Okay, so part B, wrote my equation, good, check. Part C, take the derivative with respect to t. Bless you, having a sneezing fit here. Okay, take the derivative with respect to t. All right, we got this V sitting here. What do you think its derivative is going to be? dV dt. Because the derivative of a single letter is just 1, so we just leave the 1 off, dV dt. Equals. Okay, next is a 4/3 multiplied to a pi. Those are constants. Constants always sit there. So let's just copy them down. 4/3 pi. They just sit there. Now, what is the derivative of r to the third? 3r, what power? Squared times dr dt. There we go. Every time you take the derivative of a letter, you got to put d letter dt. Okay? Take the derivative with respect to t. Check, we did that. Part D, plug in the quantities from part A, all those variables that you set up, and solve for the remaining one. Now, you should have numbers for everything. Or, if you don't, you should be able to solve for the one you don't know. Do I know what dV dt is? It's -1. Don't bring its label along. You don't have to. Equals 4/3 pi times 3 times r. Do we know r? Yeah, it's 10. 10 squared. Do we know dr dt? No, that's what we're looking for. So, okay, that's good that we left that alone because that's one we want to find. Okay, so now we have this. I need to clean this up. We're going to leave the answer in terms of pi. We're just going to clean up the mess and just leave it in terms of pi. So, -1 equals 4/3 pi times 300 dr dt. What is 4/3 times 300? Hopefully you can do that without a calculator. 3 goes into 300 100 times. So now we have 400 pi dr dt equals -1. And to get dr dt by itself, we divide by 400 pi. So dr dt equals negative 1 over 400 pi, but it needs a label. Okay. How are it's per minute. I know that because everything else is per minute. Now, because it's a radius, is it centimeters, centimeters squared, or centimeters cubed? Radiuses are linear measurements. It's just centimeters. Okay. Part B is done. Part E, write a sentence stating what you found. Be sure to specify whether it's increasing or decreasing. So, it says at what rate is the radius well, it tells you decreasing. The radius is decreasing at, drop the negative, 1 over 400 pi centimeters per minute when r equals 10 centimeters. You need that stipulation in there because that's the only time that it's changing at that rate. Like we were talking about the volume of the popcorn, how it went up and then it leveled off. Are we talking about when it's at the bottom? Are we talking about when it's in the middle? Are we talking about it when it's at the top? We're saying we're picking a point along the way and we're saying that's how fast it's changing at that point. All right? Any questions? Do you see how the ABC, excuse me, do you see how the letters walk you through the problem? That's what I want you to do. All right, you guys have 10 minutes. Your assignment for today, this is a little different than what's on the calendar. I want you to work with your table the rest of the period and get as much of the next few problems done as you can. Let's look at them real quickly. Number 2 talks about moving along a curve. Number 3 is very much like the Phoebe-Calvin problem. Okay? Walks you through all of them. Number 4 is a little bit harder. I don't expect perfection. I do not expect you to have this thing totally done by tomorrow. I want you to get as far as you can, and then tomorrow we're going to come back, get with your table, see if you can get the rest of the way. We're going to spend the whole period tomorrow working on more problems like this, because this is something, the only way you're going to get better at it is just to practice on it.